Okay, so we are on to a special case of factoring. So the next few sections are going to look at special cases, essentially. So what happens when you have something called a difference of squares, which is what we're going to do today. And the next lesson is looking at how do we use a factored equation, and then what happens if an equation can't be factored by one of the methods that you've been taught? What do we do there? Okay, so and that's going to basically take us to the end of this section. So just as a reminder here, when we're going to factor these, so this first one has no common factor because there's no value out front of the a here, or the x squared. So you're looking for two numbers that multiply to 45 and add to negative 14. So really, there's not much that 45 is divisible by. So this one is not a bad one. You could do 1 and 45, but that's not going to work. 3 and 15 gets us close, but not quite. And then 5 and 9 will get us 14. So then if we want negative 14, it has to be negative 5 and negative 9. Doesn't matter which one you write first. Okay, the second one looks almost tricky, but remember to common factor first. Okay, so then if you divide them all by 3, so again, one of the good news is about common factoring, usually you can often look at the a value and see if it's possible to divide the other terms by that value. That's a good indicator that, or that is a good option usually for a common factor, okay? So now it is more simple, like the kind that we just did in A. So you're looking for two numbers that multiply to negative 12 and add to negative 1. So there are a few options for 12, 1 and 12, no, 2 and 6, no, and then 3 and 4. So since we want it to be multiplied in negative 12 and add to negative 4, we're going to make the 4 negative, which gives us negative 1. 3 plus negative 4 is negative 1. If you are starting to, make peace with your multiplication tables, or you are better able, maybe like the 1 and 45, you knew that one wasn't going to work, then you don't have to show them all. But if you do some and write them down, then you'll know which ones you've tried. Or if it doesn't work out, you can go back and check a little bit easier. So even just quickly jotting it down, showing your work, even if you're going to do guess and check, sometimes that can be a little bit helpful. Okay. And then we have 2x minus 11x plus 12. None of those will have a common factor. So what we're going to do is you have to do decomposition or magic X or guess and check. So when you do that, it's AC multiplies to give A times C, which is 24, and adds to give negative 11. Okay, so when you have 24, it does have quite a few factors. But again, 1 and 24 is probably not going to work here. 2 and 12, no. 3 and 8, oh. If we do negative 3 and negative 8, we'll get negative 11. Okay, so you can do or you could do okay, it doesn't matter. So if you choose magic X, you have to divide by the a value, so this number here, and then reduce the fraction if possible. And then these become your factors. The 2 goes first, 2x minus 3. And this one is just 1, x minus 4. So over here, The common factor in these ones is x, so you get 2x minus 3. And then over here, it's going to be negative 4. And you're going to be left with 2x minus 3. So now our common factor is 2x minus 3. And then what's left over? X minus 4. So you get the same answer. So this one's a little bit wacky over here, but let's see what our common factor is. So when you have variables, you always want to look for the one that is the lowest. So the lowest exponent, so that's going to be x. And then for the y, there's y cubed, y squared, and y. So y is the lowest. Oops, sorry, there's no x there. And now this, even though those are y's, you can still factor it like we've been doing. So now the common factor is xy. This is a rarer case, but it's still possible. So multiplies to give 1, adds to give positive 2. Well, the good news is there's only one choice, has to be 1. Positive 1, positive 1. You can also write this like y plus 1 squared. Okay, so that's a review. Now let's look at our special case. So when our special case today is going to be when you have a square term. So a square term is a result of the term that is multiplied by itself. So 1 squared is 1, 2 squared is 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, okay, and so on. So when you, actually, let's do up to 12. When you have these, maybe you're not good with squareds, but what's going to happen is when you have a difference of squares, you're actually going to get a question that looks very unique, okay? And so then hopefully that's a trigger to you. Oh, okay, I think this is a special case, so I need to be a little bit careful here. And you know, sometimes people are like, well, special case, how often does this come up? You would be surprised how many situations can be modeled by a quadratic equation. And then, so that's going to be one of the lessons. We're going to talk about what kind of problems can be modeled by these equations and how many can be modeled using difference of squares, especially in science, those of you that are into that too. Okay, so can a square term involve variables? Sure they can. So the only weird thing is though, when you multiply numbers together, you add the exponents. So x times x, when you add the exponents, is x squared. That's, you can square root that. When you do something like this though, you do have to be careful because that's x to the 6, which is not a squared term. So you do have to be careful with these. But usually what you're going to see is a term that has x squared in it. So then it's pretty obvious that it's a squared term. Can binomials be squared terms? So you've already seen this. We just did one, y plus 1, y plus 1. And I really haven't stressed that you had to write it like this. And in fact, when we do FOIL, we usually encourage you to write it out, not leaving it as a squared. But there is a bit of a shortcut you could take. Okay? So yes, they can be squareds. And actually, this kind of thing will be important in science as well. Or next year when you take, should you take grade 11 and you multiply binomials like this, then you'll cancel the bottom and take away one of the tops. So square rooting basically, but that's next year. So you don't even have to write that down. Oops. Are these terms square terms? So basically we're looking for, can you square root these numbers? Can you square root 25? And remember, we're not doing decimals, okay? So similar with factoring, no decimals yet, we want perfect numbers. So yes, you can square root 25. Can you square root 10 evenly? No. Can you square root 144? Yes. You're going to get 12. So the square root of 144 is 12. And then the square root of x squared is x. Can you square root 4x cubed? Nope. Can you square root 100y squared? Yes, you can. Can you square this? Yeah, so this is what we just talked about. Okay, so if you square root that, then basically one of them cancels out and you're left with one term. Okay? All right, so let's review expand and simplify first. So this is first, outside, inside, last. So the first here would be x squared, as always. Then the inside is 4x and negative 4x. And then negative 4 and positive 4 makes, oops, I almost wrote positive there, negative 16. So if you'll notice what happens in the middle here, these two, positive 4x and negative 4x make 0. And usually we don't write 0, right? So that becomes x squared minus 16. So now we don't have a b term. Is that okay? It sure is. And that is going to be our special case. All right. So here, so let's just continue and do these all. So even something like this, 2x times 2x is 4x squared. 2x times positive 7 is positive 14x. Negative 7 times 2x is negative 14x. And negative 7 times positive 7 is negative 49. So again, you've got a squared term here, 4x squared. These two are going to cancel. 14x plus negative 14x is 0. And then you're left with the squared term at the back. And then here, we're going to just leave that 3 for now. And you get x squared plus 5x minus 25. So let's simplify. Okay, so even though we have this common factor out front, which you can do at the end, and so then there are tricky questions where you have to common factor first, as always, and then you can do the difference of squares. But if you'll notice, we have, like these, all have a similarity, right? They have no b term. And the first term you can square root, and the second term you can square root. Now, can you square root negative 16? No. So you're just looking at the number. Square root 16, square root 49, square root 25 once you divided out the common factor, okay? So don't think of it as square root negative 49. It would just be the square root of 49 is 7, okay? Because that is not workable yet. Okay, so let's do one with letters to get sort of a general idea. So m squared minus mn plus mn minus n squared. So these two cancel out in the middle here. And you have two squared terms and difference, right? It was called a difference. Let me see if I can pick a different color here. Difference means subtracting. Okay, so all the solutions result in a binomial. So binomial means only two terms. Where the two terms are being subtracted, this occurs when you multiply two identical binomials together, where one of them is adding and the other one is subtracting. So all of these have an subtract, add, subtract, add, subtract, add, plus, minus. So it doesn't matter which one has the plus and which one has the minus. They just have to be exactly the same, except the sign in there, okay? So let's do some more examples. So when you factor these, you're thinking, you want to draw a little thinking bubble. Can I square root 100? So these look unique because you're used to, say, x squared minus 50x minus 100. I'm not saying this works. I'm just making it up. You're used to this b term in the middle here. There is no b term in all of these, right? just two terms, two terms, two terms, two terms, okay? So can I square root 100? Yes. So then what's the square root of 100? 10. Because we're dealing with quadratics, the first term is always going to be an x. It's always going to be x squared in grade 10, okay? So that makes your life a little bit easier. And then you just have to remember, make one plus and make one minus, okay? So let's write that down. Terms, square root terms. One set of brackets is adding and one is subtracting, okay? Not too shabby. So now it says square root terms. So here we have an x squared, which is fine, but we also have a number here. So you have to think of your square rooting this and square rooting this, okay? So now you've got 5x instead of just x, but that's okay. That's no big deal. And the square root of 64 is 8. Now, should you stress if you don't have square roots memorized? Of course not. But when you see a weird with no b term like this, like these ones here, then hopefully that's your trigger in your head. Oh, try square rooting. And then if you don't get a perfect square, then there are other ways to deal with that. But it should be pretty straightforward. Okay, so then we have square root. This one, square root 49, 4x squared, square root 49. So you get 2x squared. Oops, not 2x squared. 2x and 2x, and you get 7 and 7, and the plus and the minus. You can also think of it like when you're square rooting something, you always consider the positive and negative answer. There's always 2, right? So you can look at it that way too. Now this one down here is missing that b term, okay? But it looks weird why 50 and 32 are not perfect squares. What do we always check for first? A common factor. Okay, so then what can we divide these by? Well, we can divide them by 2, and then we're going to get 16x squared, and 25. Now, are these both factorable? Yes. So square root 16 is 4x. Sorry, square root of 16x squared is 4x. Square root of 25 is 5. One of them plus and one of them minus. Okay, so you're looking for that unique binomial here with no b term. But again, the hardest ones you have to common factor first. Okay, this question is, let's just cross it out. We're not going to deal with this in this time now. It won't look like that. Okay, so always remember to common factor first. And there's not that many questions for homework, so give them a try. So now this last page here has sort of a factoring flowchart, I guess, if you like that kind of thing. So always common factor first. Sorry, that's not very good, is it? Trinomial means 3 terms. Binomial means 2 terms. Okay, so then when you have 2 terms, is it a difference of squares? So what we just saw, is it like x squared minus 25? If it's not a difference of squares, then you're done. So say you common factor and it's one of those weird ones from like the first day. I don't know, x, z or something. Okay, so something weird like that, then that's not what we're dealing with. You don't have to factor that further. Then if you have a trinomial, which is 3 terms, so like this kind, ax squared plus bx plus c. If a is 1, then you just do the t-chart, two numbers that multiply to c and add to b. And then when a is not 1, you have some choice. So decomposition, magic X, guess and check. But you're always thinking a times c and b, that's the difference there. Okay, so give these questions a try, and if